Hi. So one of my students came up to me and asked me about hydrostatic forces, and so I decided to go over this information as much as I can because I didn't understand hydrostatic forces either until I started looking at some YouTube videos. So it says a large tank is designed with ends of the shape of a region using the curve y equals 1/2 x squared and y equals 15. So this is what actually the tank looks like. It's y equals 1/2 x squared, and y equals 15 will be the top right here. Measured in feet, so everything's in US system. Find the hydrostatic force on one end of the tank if it is filled to a depth of 5 feet with gasoline, and assume that the density of gasoline is 42 pounds per cubic feet. So we know that the force is equal to rho. Rho is the density times the gravity. Gravity is 32.2 times the cross-sectional area of that times the depth, where D is defined as depth. A is equal to the cross-sectional area. And G, rho, which is the density of gasoline, is equal to 42 approximately, 0.0. And of course, G is approximately 32.2 feet per second squared. Okay, that's in US units. So if what I'm going to do is if I add up all the forces, basically what I'm doing is taking the integral of this from a certain amount. Okay, so the total force is equal to, I'm going to take out density of the gasoline and gravity and factor it out, rho times G, and the cross-sectional area times the depth that it has. Well, if we look at this is 5 feet because it has 5 feet of water. 5 feet of gasoline, excuse me, with a depth of 5 feet. I have to look at what the cross-sectional area of this parabola is. And you notice that this is your x-axis and this is your y-axis right over here. And notice also that the cross-sectional area is going to be in terms of delta y or dy. I made a first mistake in assuming that it's delta x, but of course, assuming that this is delta y, so we have to use delta y here. So what is the area? Area is equal to length times width. The length is this length, right? And this length is going to be x, from here to here is x, and you're going to just double it. So the length is equal to 2x, and the width is going to be dy. The depth is, this is your depth right here, from the top of the gasoline to where the cross-section area is hit. So if this is 5, and this length is y, from here to here, then the depth must be 5 minus y. And so we plug it back in. So the force total is equal to rho times gravity times the area is 2x times dy times the depth, which is 5 minus y. Well, the x has to be in terms of y because we are using dy's. So using this formula, y equals 1/2 x squared multiplied by 2, 2y is equal to x squared, x equals square root of 2y. I'm going to plug this into here. So that's equal to rho times g times, the limits of integration is you're starting off at 0 feet, starting off at 0 and you're going up to 5. So this is from 0 to 5. 2 times x, which is square root of 2 times the square root of y. That's the same thing as square root of 2y. times 5 minus y dy. I'm going to factor out 2 root 2 over here. That becomes 2 radical 2 rho times g times integral from 0 to 5 of, I'm going to distribute the square root of y with 5 and change into exponential state. 5y to the 1/2 minus y to the 3/2 dy. Okay, and I found out this value. If you plug in 42 in here and 32, I get approximately 3,800. 3,800. And I used my calculator. You actually don't need to use your calculator, but you can have a radical state. This comes out to you approximately 14.9. And we multiply by that. And I have no idea what that is. 3,800 times 15 is 57,000. So that's approximately 57,000 pounds of force, total force. Okay. Good luck, and let me know if you need anything else. Of course, let's do a recap. The force is equal to the rho, which is the hydrostatic. The rho is the density of the material times the gravity times cross-sectional area times the depth. And if you add them all up, the total force would be the integration of that, because the depth is a function of how much cross-sectional area there is. So that's why over here, 5 minus y would be the depth. Cross-sectional area, this got a little bit tricky, 2y times dy. And then integration from 0 to 5. Good luck on your exam tomorrow. Matthew.